what the new SciAps laser technology does is it fires what are called laser bursts. So instead of a single pulse of laser energy, it'll fire 5 or 10 pulses in that tenth of a second. And so it bursts those pulses. You get 5 to 10 laser pulses in a tenth of a second that just burns through all the surface material. And then the analyzer sends more laser pulses into the material to use it for the data to do the chemistry and the grade matching. It was developed especially for these complicated, sort of real world materials that you don't want to have time to clean and grind. All right, so first thing is we've got a bunch of different pieces of aluminum scrap here from a handful of different recyclers around the region, and we've selected this because it's got probably the most surface contamination we've been able to find. So let's start with some 6061. First, maybe an easier one. Here's a piece of 61 straight out of a scrapyard. This side has been ground. This side has been untouched. So let's shoot that first. The first thing you'll see, you pull the trigger. In about a second or so, you get a 6061 match, and you're done. There you go. So absolutely no surface prep, no testing, no nothing. And we can actually, just to make sure, we'll just arbitrarily shoot that again, a second spot, pull the trigger, 6061. And you look at the two measurements. Let's do it one more time. 6061 in a couple of seconds. And just to, those are two different spots, and just to show the results, the one spot was about 1.1% magnesium, chrome about 0.12, copper 0.21. The test before that, 102 mag, 0.11 chrome, 0.18 copper. So great repeatability, no surface prep, and a couple of seconds, and there's your 6061. Now let's take a harder piece. Here's another piece of 6061. As you can see, it's got all kinds of surface stuff on it. It's got some, I want to say it's rust, but it's got some discoloration, some dirt. So let's go and shoot that next. Couple of seconds, there you go, 6061. Let's go and pick a different spot. Again, staying on the dirtiest area we can find. Intentionally pick a different spot, hit the trigger. Okay. 6061. I wasn't quite flush with the window at first, but now it is. And again, look at those results. Two different spots. Again, very good repeatability. 1.4 mag, 1.5 mag, very good. So for 6061, which is one of the more common alloys, those might take more than 30 seconds or more with an X-ray device because of the need to see the magnesium. These we did in a couple of seconds. No prep, no nothing. And that's all because of the new laser technology. But here's another good piece. So this is as you can see, it's a real world 6063. We'll hit that. Again in a couple of seconds, 6063. See, the magnesium is lower. There's no copper, there's no chrome. That's what makes it an exact match to a 6063. So that was good. Let's do a really challenging one. This is, as you can see, quite dirty. This region has been prepped. We're not going to shoot that region. We're going to shoot over here where there's been no sample prep or cleaning whatsoever. So let's shoot that. Shoot that. Get it on there. Pull the trigger. Couple of seconds. 3003. See about that higher manganese, low mag. So that's good. Let's move to a different spot. Maybe move up here. Do it again. Again, 3003 in a couple of seconds. No sample grinding, no nothing. And just to show that this isn't just about grade ID, if you look at the two tests, 1.1 manganese on the first test, 0.9, and look at, well, magnesium's very low, silicon's very low. So anyway, good sample, good testing on what is a very hard piece of scrap because of all the surface contamination on there. And I don't think you'd be able to do that with any other type of laser because you need that. You need those rapid fire laser bursts that comes out of the SciAps unit that burns into that material. So let's see, that's a 3003, 61, a 63, Here's another one. It's 5052. Again, same thing. If you look at this, you'll see a couple of areas where the it's been cleaned, but we're gonna shoot over around here, over on the edge here where there's been no cleaning. Same with that side. So let's shoot that. Seconds should say 5052. It does, up around 2.5% magnesium. So move to a different spot that also has not been prepped in any way. 5052, again, 2.5% magnesium. So good chemistry. Good chemistry, good speed, no prep. And probably the final thing to look at, we've got some shredder residue here from one of our customers. I like doing this because this is straight out of an automobile shredder. The lights have been pulled out of the Zorba, but let's take this one. Again, the same kind of thing. You see there's an area that somebody grounded and hit it with a spark optical emission, but we're not gonna do that. We're gonna shoot it in here where there's just nothing's been done to it. So let's pull the trigger there. I had pulled it a little off the surface of the material, so the reading might have been a little bit high, but it was still within the spec of the 61. Shoot another spot. 6061. Perfect match. That's good. So yeah, it's a piece of shredder residue. Let's do this one here. This is same thing. This is an 1100. Ground here, spark there. But we're gonna flip it over, do the side that has had no prep at all. All right, this is one of the more pure aluminums, and I like doing this one because if you've got surface contamination, it'll show up as elements being identified that aren't really in the material. So 1100 is a great example. An unclean piece of 1100 should come up 1100 if you're doing the surface analysis correctly. So let's just find the spot here, hit it. Flush. Be expected. Let's try to find another spot. There we go. Just 1100. Nothing but lube with a silicon and iron detected, which is a surprise. You'll find that. So very good results on that. So we've done 1100, 60, 61. Here's another piece again. See, there's a cleaner area and a totally unprepped area, so we'll shoot the unprepped area. So let's shoot that. 3003. This is what it is. But the thing I want to point out here is that you'd never do with an X-ray device. All these pieces, I've just been picking them up in my hand and holding them here and firing away, and that's because this is a laser device. There's no X-ray radiation, there's nothing harmful, so you can just shoot away and no danger at all. So you can never do that with X-ray, but I think it's one of the real conveniences of LIBS. You can point it right on the material in the bin if you want, but for smaller material or stuff that's harder to reach, you can just get it and pick it up with your hand and shoot it. You don't have to get a test stand or some sort of shielding. So that's it. So that's how we do unprocessed, unclean scrap. It's very fast, as you saw, good chemistry, and no surface prep whatsoever.